Really going to do some introductions, a little bit of logistics around Zoom. Then we'll kick into the content where just open it up for a general conversation about what observability means to various people. Alan's going to do a piece on observability from the outside in. I'm going to take back over with some content really around the kind of the support story or the platform engineering side of this. And our good friends at Sumo Logic are going to do a quick demo for us before we get to a Q&A. So hi, my name's Piers. I'm a consultant here at Assurity. I have been working in systems operations largely and DevOps for the last, I don't know, 6 or 7 years. I'm co-presenting today with Alan. Alan, do you want to say a quick hello?
Hi, my name is Alan. I guess I'm a principal consultant with Assurity. I head up our DevOps service line and our DevOps education. I've been in development and DevOps for the last 5 years, development for the last 25 years. Been around for a while. Observability is this, relatively new concept in the last couple of years as our systems have gotten much more complex. But our thinking about how to make those systems operatable and operable and easier to understand what their state looks like has not grown as fast as our complexity of our systems has. So yeah, that's what interests me about this. I think that's good.
Cool. So for anyone that's just joined the call, we will be recording this. A couple of people have RSVP'd and asked for recording. If that's not something that you're willing to participate with, feel free to drop off the call. We can send the recording out, but the community does really value your input. So just with respect to using Zoom for this meetup, a lot of people find the tooling kind of a little bit new and novel. A couple of things to just ask me as a presenter. It really helps me to kind of be able to see your faces to gauge the reaction of the room. It's much easier than talking to the void. So there's a couple of you with the video on, appreciate it. It is a small group, so if you would like to leave your mics on or just shout out with questions as we go, would be much more preferable. If you're not an extrovert and you'd prefer to use the Zoom chat or Zoom reactions, feel free to use those too. And then just, as a courtesy, just remember that everyone's coming from a good place, so please be kind and respect the group. So to start with, let's think about the topic of what observability is. So I stumbled across this rather cynical tweet from Cindy's Shredden's feed around observability being really what devs don't want to, how they don't want to do monitoring anymore, and they want to rename it, repackage it, and call it observability instead. Now, I don't think that really kind of captures the nuance of what the difference between monitoring and observability really is. So what I like to think of it is a kind of a series of questions that explores the new and complicated systems that we run and maintain, kind of starting with, does it currently work, or is it currently not working? That's kind of like a binary state. And it actually doesn't take a lot of sophistication frequently for consumers of a system to understand this. I am not a internal combustion engineer. I do not understand really at a deep level how a car engine works, but I know whether my car is going to switch on or not, if it's going to take me to the supermarket or if it's just not started. So that's kind of like a very simplistic and quite often the kind of the persistent traditional view of what observability might be. But I really feel that is more just the kind of bare bones monitoring picture. Kind of taking that a little bit further, I'd like to think that in a modern kind of observability solution or set of tools, we're probably going to start getting evidence about things that might support our view about whether the system works or not. So this would include kind of evidence about what subcomponents might be working or not working, what information we might have that describes the nature of the challenge that we're having if things aren't working. But even that, I feel, is not quite the end goal. I feel as if taking another step back and asking ourselves, how did this come to be? How do we get ourselves into this state? Is really the objective of what we're trying to achieve with a modern observability approach. And that can cobble together information from a number of different facets, a number of different external tools, or it could be inside a single solution. And I don't think that's as important as being able to reason about the order in which an event might have occurred and to identify a series of potentially contributing causes. Cool. So I'm going to flick over to Alan now. He's going to talk a little bit about kind of the observability, as an end user or from the outside of an organization.
Thank you, Piers. So, with observability really comes from control systems theory, and it predates our technical system by quite a while. The real idea behind it is to be able to infer the state of a system from the outside. And so, as Pierce's example, very simplistic, does it work or not? That's a very, very basic way to look at the internal state of our systems. In the last couple of years, the way that our systems are built has become infinitely more, not infinitely, but a very large factor, more complex. And as a result, being able to infer what's going on inside of that complex system has gotten progressively more difficult. Couple that with the fact that for many years, most people didn't really have to think about the complexity of the systems in which their code operated. As a result, they didn't really think about how you observe the system from the outside. Well, I like this image here. This was from a tweet from one of the folks at Honeycomb. And it says, it's a cross stitch. And so as you look from the outside in, all you see are the nice interfaces. And you might see different colors on those interfaces, of course, in the cross stitch world. But then when you turn the cross stitch over, it's not anywhere near the external view. This string is attached down here to this bottom left corner. It's just a wild and unkempt solution. It's very hard to actually infer what the external interface is looking at the backside of a cross stitch. And of course, that all depends on the skill of the cross stitcher. Of course, much more skilled cross stitchers like my great aunt. She's a firm believer that the back of the cross stitch should be in order and kept place as well. So it's one of these things that has a little bit of philosophy to it. What that means, when you're looking as a user of a system, there's a lot more information that we can present through the use of metadata to those requests and those responses that a user may, an end user may never notice. But our systems can notice, and they can give us a much more granular indication of what's going on inside of our system from external monitoring. What this really requires as you're building these systems is forethought into this idea of instrumentation. So that would be the next slide. Yeah, there we go. So when we think about instrumentation, there's a lot of different ways to do instrumentation. And, the ultimate goal is to make the internal state visible externally. If you are a user, let's say you have, 10,000 users of your website. And of those 10,000 users, let's say, 10% of them get an error back. And that's all you know. if you have an external monitoring setup, all you know is there is one or more problems. You don't know anything else about those problems. So observability is really about giving that granular level so that you can really infer what's happening from the outside. So I kind of call these needle in a haystack issues. Think about like an interface that uploads a file. So, you know, if this is over HTTP, I mean, your protocol is kind of indifferent here, but if we're over HTTP, you might send a request with, you know, an expect header, say expect a payload this large. And then, you know, if the server is modern and ready, it'll say, all right, go ahead, here's 100, go ahead. And then it'll send that payload. That's a long-term connection. And in anything with networking that, you know, is long-term, it can be disrupted. Connectivity issues can be a real bear. It's important to think that, you know, any request to any modern website goes through, you know, up to hundreds of pieces of network infrastructure just to get there. So there's all sorts of things that can go wrong for a long period of time. If that happens and all your system does is report back an error, you know, a generic error, you couldn't tell the difference between, oh, my network connection dropped, to the file was corrupted, to, you know, I wasn't able to process it because of disk space. And so if all you're doing is reporting on errors, that doesn't really give you those indicators, those SLIs, that you need to really drive your understanding of the system. So, you know, there's several ways that you can do this, and it really depends on your systems that you're building. The first thing is, you know, if you're coding your systems and you're building them right there and, you know, writing them from scratch, you've got an immense amount of power in what you can do in terms of instrumentation. You can instrument right there at the code level. There are some drawbacks to that. If you start instrumenting at the code level, that can quickly become overwhelming, and there's probably smarter ways to do that. So if you've got 100 microservices that you're instrumenting at that code level, that's a lot of complexity with not a lot of control over the entire fleet of microservices. So, you know, another strategy for instrumenting, you know, for that external view is doing something called onion skinning. So, I mean, some of you are probably familiar with onion skinning. It's the idea is that you basically put a wrapper around a service or a fleet of services, so like a service mesh, that monitors all the traffic that goes in between this and the outside world. That sort of strategy, onion skinning, can give you a whole bunch of information about the flow of information through that interface. It's kind of like the electrical engine, you know, in electrical systems, you can measure potential in parallel, but if you want to measure what's going through, you have to measure in series with the circuit. So you have to, and that's really what onion skinning is all about. There's a lot of tools to do that, and it really depends on, you know, what your infrastructure looks like, and what you're building your systems on as to what tool you can use. But, you know, that sort of thing can give you two different contexts. I mean, in this world, there are connections and there are requests. And you might hold a connection for a very long time. And that connection might have multiple requests within it. One is a much more technical understanding, like what we call layer 7 observability, that you're really observing that layer of the networking paradigm. And one is actually understanding what's actually happening with the information inside. So that's that request bit. With the requests, if it's an HTTP request, it has an error code that it comes back. And I like to think of the HTTP error codes as a box of crayons. And I can color my system in all different ways with those error codes. I can say that, you know, my payload wasn't as expected. I can say that I had a connectivity issue. I can say that, you know, I crapped out, big service error. You kind of have the 400 series, which is problems with the request, and the 500 series, which is problems with the server. You even have, and this is the interesting thing about HTTP, is it's you know, the standard is built off of, you know, just a community kind of deciding what codes need to be added as individual situations have come up. And so, I mean, I guess in April Fools many years ago, the HTTP group introduced the "I'm a teapot" error, and you know, it has now persisted. So it's one of these things that we're building really, really serious systems on and really, really reliable systems on, but there is a little bit of a joke that's kind of running through it. So quite interesting. The real idea with instrumentation, I mean, you can instrument a lot of different things and push a lot of different information out through the metadata of a request. Even more than error codes. You can, you know, do things with HTTP headers. You can respond with, you know, stack traces and things like that. You can say, you know, here's the GPRC method name, and this is where it failed. And all this sorts of information, if you have the right kind of observability system, can give you a lot of outside-in view of the state of your systems. All right, I think that's all I got. Does anybody have any thoughts on outside-in observability? I don't want to just sit up here and pontificate. I would like a community chat.
Alan, what are your thoughts on the use of things like Google Analytics, which kind of purport to be external monitoring kind of concepts, and whether or not they lend themselves well to this use case?
Yeah, well, Google Analytics, you can instrument like front-end code quite granularly with things like Google Analytics events and things like that. Those types of things are really geared towards e-commerce, right? And you're not going to necessarily get the right kind of information without kind of pushing the system operation kludge onto an e-commerce kludge. And so, I don't know, Google Analytics, in my experience, has given us, you know, a way of doing observability, but not necessarily a great way of doing observability. Yeah, I mean, like with the events, I mean, events would be probably the thing you'd use in Google Analytics to get some sort of instrumentation. You really can only like do, if it's at the event level, you can't get like information about, you know, where was their mouse hovering, or, you know, how long did they take to click these things. You need to add a little bit more instrumentation to your front end to get that kind of information. There's tons of tools that can do it. Amazon Incognitos are really
Seems
good.
to me to be aimed more at the marketing side than it is on the operation side. But
yeah.
I'm interested to know if anyone's had success with it. Awesome. Let's move on. Thanks, Alan.
All right. Cheers.
We've used it.
Oh, Brad's got something.
I was going to say we've used Google Analytics, as you said, more for the marketing side, but also to look at things like types of errors that are occurring. It's a quick thing to, like, you know, instrument a new type of information into, or a new type of event into, if you're trying to diagnose something. One of the questions I might ask is your thoughts about the fact that there's so many different types of tools for understanding the behavior of your application. So I used to be a big fan of Splunk back in the day, and I've never found Kibana quite the same. But having one place to look at, you know, as the lake of all the stuff that's going on was really good. You know, later finding things like Raygun, and, you know, you go to, you know, CloudWatch, and you've got all this stuff everywhere. Your thoughts about consolidation, and then you got the Grafana instance, and then the Kibana instance, and you know, thoughts about getting the one overview.
Well, I mean, I don't think anyone's kind of cracked it just yet. I think that it's a really good segue to this slide, actually. The kind of, if you're putting on the kind of system administrator hat, or someone who's kind of been an operations engineer kind of tasked with the support, there's so many different kind of types of information that people leverage in order to understand how their system is performing. And so, you know, the 2017 view is kind of the picture I've got on this slide here, where it kind of divides that machine data into kind of three major sources. So you've got your metrics, which kind of probably fall mostly into that monitoring level of observability. Got logging information, which kind of gives you kind of more of an event perspective on that. And then the kind of, I guess, the newcomer, what APM offers around tracing, or being able to understand not only what request did the consumer of your services make, but how did that transition through all of your infrastructure and get pieced together in a logical sense. And so from that machine data, we start to present things like a dashboard here. So I've got metrics as the title of this slide, but what you're looking at here is not a metric. What you're looking at is a graphical representation of a metric. I mean, the metric here is going to be a series of timestamps with a series of simple numbers alongside it. And those properties make it really efficient to store a lot of information. You can kind of degrade it frequently. You can kind of take per second time slices and then kind of work out what the total number of hits might have been in a minute, and then kind of downsample. And this is this is the sensible place where most organizations start their observability journey, with the kind of simple kind of metric management. And then kind of presenting that information back on dashboards. And that can work really well if you've got a 24/7 NOC where people are constantly staring at a pane of glass or a number of panes of glass, but possibly don't scale to the level of a sophisticated follow the sun type of requirement. The second major source of machine data is the log, the good old system log. So they've kind of changed a little bit over time. So, where we might have traditionally taken a web request and written a single line, maybe it's a comma separated line that goes into a file, one file per server, and it's pretty straightforward. Every request means one line with a timestamp and some, key information about that request. That's kind of transformed a little bit over time to a slightly more structured logging standard. Those flat files are still widely used, but this JSON idea of having a little bit more structure to the log file, and kind of allowing more sophisticated tooling to make associations within data. This kind of structured data approach, structured logs, so it's quite often referred to as semantic logging, is really powerful. There's some kind of gotchas around this, where not the least being that you can pay a fairly high price over the long term for storing a lot of this information that you're not really using. I have seen this kind of approach using a log in order to kind of generate a metric, which, as I said on a previous slide, is really kind of a cost-effective way of storing time series data. When you think about how much more kilobytes per signal you're storing here with a large log file, that gets to be ramp up in terms of kind of cost over time. And so even simple things like recycling the logs on a server, you start making you think about some infrastructure that you need on top of your customer facing infrastructure in order to kind of manage those logs. And a whole swag of kind of products in this space emerged, not the least being Sumo Logic, who we'll hear from later. If you're interested around kind of managing logs at scale, an old colleague of mine has recently written a blog. It's in the references. His name's Ethan. He's written a lot about how to kind of manage your log ingest over time. So I encourage you to go and have a look at that article. Cool. And then the third kind of major source of machine data is this kind of tracing idea, where you get a customer request as your kind of that long line there that says 181 milliseconds, and then kind of follow that through the different elements inside your stack. And obviously, in order to do this, you need to be able to tie all of the information together. You need to be able to understand the order in which events happen. You need to be able to kind of retrieve the span information in a relatively short amount of time. And obviously, when you look at how potentially intrusive this is, it has an overhead to it as well. So you will obviously need to be very careful not to impose too much extra latency to the consumer's request. Often that's achieved just by doing a sampling or only kind of enabling such a perspective if things start slowing down over a certain threshold. So there are tools in this space that are kind of open source. So famous ones would be Zipkin and Jaeger, but there are other APM providers out there in the market that I'm sure you'll explore. This is kind of the more sophisticated end of machine data and can tell you quite a lot about why the user that's on the other end of your phone call who has an active support ticket had a particular issue at a particular time. And it goes a long way to answering kind of why do we get ourselves in this state, but not necessarily information around what changed in your system. So that would be a key piece of information I'd also be wanting to supplement on top of this. When did we do a system release? When did something change operationally? Did one of our providers have an outage? That's the kind of key piece of information I'd be looking to supplement this with. Cool. So if you've worked in a kind of operations scene for any time, you'll have encountered this kind of wall of red on occasion. And we can use this machine data obviously to kind of trigger human response. Quite often this is kind of out of a mobile phone, which can go a little bit crazy at times. And so what I'm really encouraging is that a sensible strategy be put in place in order to kind of make the alerts something that you can manage and not fatigue your team with. So there's a couple of things you really want to kind of consider right off the bat when you're formulating that kind of strategy. Firstly would be kind of, can you actually do anything about this? Is it an actionable alert? Does it really require a human being to do something? And if not, maybe that information needs to go somewhere else. Perhaps it just needs to be informational. Go to a Slack channel or go into, go for a bit of email or somewhere else for kind of, you know, when you roll up into the office the next day, rather than waking someone at 2 o'clock in the morning. A couple of things that you might want to think about is the kind of Google SRE concept of establishing service level objectives, kind of understanding about when a potential issue is actually impacting customers. So taking Alan's ideas around external user expectations and making those a little bit clearer, and alerting when you're failing to meet what your customers would expect as good service. And that's kind of very closely aligned to that idea of, you know, if a tree falls in the forest and no one hears it, does it really matter? You know, again, if your CPU has gone high, if it's sitting at 95% plus, but no customers are impacted, why are you waking someone up? And then lastly, making sure that you've got some alerts around things that you know will impact a user if they're left. So a really classic example of this is, you know, lack of disk space. And so there is pretty sensible ideas that you can put in place around understanding what the rate of consumption is on disk, you know, how much disk you've got in total. You can actually do some predictions about when you'll run out. So again, I've got a link in the references section around from a provider who support the Prometheus toolset and how they've managed that by doing a linear prediction on when your disk space will run out. And that's useful because obviously you can detect that during office hours, and you can also make a sensible decision about whether or not you need to page someone and get them into action now versus needing, you know, being able to wait. Also, there's a layer of alerting tools which sit on across that that machine data, which have the ability to kind of correlate information, detect patterns in them, you know, take 16 different alerts and kind of say, hey, these things look like they're all the same thing, or to reroute them into you know, more sensible destinations. So you can put kind of intelligent systems on the top of these signals as well to try and insulate your operations staff. Cool. It's probably a good time to pass across to Eddie, who's standing by. He's going to show us a little bit about what this looks like in a real sense using some Sumo Logic technology.
Thanks very much. Hi, my name is Eddie Thompson. I am a solution engineer here at Sumo Logic. I'm in Melbourne. And yeah, today I'll just be talking to you a bit about what we can do with Sumo to sort of help address some of these concerns around observability. So I'll just share my screen. Can someone either add me to a panelist or enable the screen sharing? I think.
You've been made a co-host.
Okay. There we go. Okay, so SysAdmin. What do we do? Who are we? We are a machine data aggregation and analytics platform. So what does that mean? We take in your logs, we take in your metrics, we take in your security events and allow you to provide some different lenses to that data, be it operational, security, business or global intelligence. That's where we actually allow you to sort of like benchmark you against other players in the industry, see what's going on more broadly. So without further ado, we'll jump in. So this is SysAdmin. This is data that's coming in live from a travel booking website that we've built as an example. It's a microservices-based application, and we're pulling in some different logs, different metrics in a few different manners. These are all coming from some Docker containers. So as we saw before, we talk about the three pillars of observability being logs, metrics, and now distributed tracing. We cover off logs and metrics. We think we've solved the hardest part first, which was the scalability of logging, but we are working actively on our tracing solution at the moment. So I've actually got alpha customers and we're sort of dog fooding internally at the moment. So I'm very excited about that being added to our quiver as well. But we can see here, this is sort of an exec overview dashboard, something that gives people that sort of outside looking in view. What do they actually care about from a business level? And at this point, we can see that the website status is yellow and the applications and payment service status are red, which is bad. So what we can do there is say, okay, from a operational view, from a DevOps engineer, I'm probably going to have something on my screen that looks a bit more like this. Breaking down my applications into the core components of some key metrics that I'm exposing and reporting on. In this case, I can see that I'm tracking my 500 series errors from my load balancer, my response time from my load balancer, and the amount of errors I'm getting on my checkout service. These are all in red. This is something that I want to investigate further. This is a dashboard where we start to sort of get a little bit more down into the weeds, where you might be sort of investigating what's going on at a more granular state. So this here, this is just actually, this is a logs to metrics generating feature that's actually just tracking from the logs what we determine to be a successful transaction and a failed transaction. Just plotting those as a time series metric. We see here, just after the hour, we've seen the failures spike up and the successes dip. Now, about the same time, I can see that my error rate has spiked up, and I'm also just plotting this against the previous 7 days. So I can see if there's a correlation between something that's happening every time the same day, or if this is something unusual compared with previous time periods. So this one's only showing me the last 60 minutes, but there's nothing that's correlating to previous days. They're all running flat there along the bottom. Errors by node. So this is showing me that there are a couple of Docker containers related to my checkout service which do have error counts on them. And over here, this is another metric we're tracking. This is just looking at the latency on our gateway. I can see as I go over here that there's two triangles. So this is actually generated via our outlier operator. So basically this is just looking at any sort of time series data that you have, could be hit rates, latency, revenue even, but basically time series data, and it's looking for anything that's outside of the statistical norm. And in this thing here, it's traveling along nicely, it's spiked up, and those two pink triangles, they're violations. That's normally something that we would use to trigger an alert that could pop a message into Slack PagerDuty. But it means that you don't necessarily need to configure fixed thresholds. And also you're able to sort of like do an additional computation, if you like, to get a stronger sort of feeling for deltas from the norm. But this correlates with the timing of the other errors and stuff that I'm seeing. At the top here, a CPU and memory graph. Everyone's seen one of these before. They're not particularly exciting, but what they do provide us with is a call to action. So I can see here that around the same time, I've got here a spike in my CPU utilization. And I'm going to drill into this a little bit further. So click the button in the panel, and it's going to drop me from the dashboard into the metrics console. So all of these panels here are dynamically query driven. So I can see here that I've got two metric queries, one looking at the CPU total, breaking it out average by node, and the other is the memory usage. And I'm just summing that up to a total. And that's generating these graphs here. So there's the CPU usage averaged out by the node. I can see a couple which have spiked up. And the memory usage here is the dotted line that's overlaid. Now, because we've got the logs and metrics in the same platform, I've also just got a really basic log query here, which is basically saying anything across my entire application that says error or exception. And that's what's generating this heat map here. So it's just the volume of messages that say error or exception. So I can see here where the CPU and memory spiked up, that I'm getting an increase in the volume of my messages. The color's getting darker. I can click on that and it'll actually show me the messages for that particular 1 minute time slice that are related. I can see here I've got some certificate errors. I might get really lucky and see the error that I've seen before and I'm like, aha, but what is more likely is I'm going to do a bit of further investigation. I'm going to shift, click, and it's going to drop me into the log console. So I've got the same context, the same query, the same time, and I can see that same error that I saw before. Now, when I'm doing an investigation, I normally sort of want to give myself a bit more room. So I can say, okay, I saw before there was my checkout in the metrics, that particular service was giving me some errors. So let's focus in on that. Show me the surrounding messages, everything that happened 10 minutes before and 10 minutes after this message. So it's dropped out the error or exception, and it's just giving me this particular service is what I'm focusing on now. So 20-minute period, and it's given me 20,106 results, or 805 pages of logs. Now, I don't want to look through 805 pages of logs. I'm not a masochist. You may be, but I don't think so. So what we've got is log reduce. I hit the log reduce button, and basically this is our pattern matching algorithm. It iterates through every single one of those 21,000 results. It doesn't sample, looks for commonalities in structure and value, and breaks them down into what we call signatures. So as this rolls up here, I should still have the same 20,106 results, but rather than 800 odd pages of logs, I have one page of signatures. And that is something that I can deal with on a human level and actually gauge what's going on. So the first thing here, there was over 3,251 instances of the application working as it's supposed to. It's giving me some info level messages, and the only thing that's changing are the function name, the line number, the message ID, and the transaction ID. That's just basic logging, not that interesting. As I go down, I can start to see things like, okay, yep, SSL errors, certificate failed, and there's some stack traces here from my service. Generally where things get more interesting is when I flip the count and have a look at things that happened rarely. So I flip the count and I can see here, okay, my app has restarted for my checkout, and it looks like someone may have pushed a development version of code to production, which would probably explain these certificate errors that I'm having. So that sort of gives me that idea of using the metrics. That's the smoke, and then pivoting down, drilling down, and using the machine learning smarts to sort of get to the fire. That's one side of it. So the other thing I want to know is, this is my hunch. Now, solving the existential support question, what changed? So I can say, okay, log compare. I know 45 minutes ago, say, everything was working fine. So I can say, show me the same set of data, but with a 45-minute time shift. So basically, this is going to run through using the same algorithm, but it's also going to process it against a 45-minute offset of the same data set. So I'm still going to get my same set of results. I'm still going to get my same page of signatures, but what I also get now is a delta count. So I can see what the variance in the signatures is between the two periods of time. So as again, normally the greater the variance in the numbers, the more interesting. I flip the count and I can see these errors are gone and these are new. So that means that's something that I haven't seen before. It's something anomalous. That is what has changed in my environment. Because that's a piece of metadata, that is something that I can actually filter for directly. So I can say where is new type and run the query again. And basically, this is going to only return me signature results which match that particular metadata flag. And this is sort of where we move from a reactive posture, actually investigating an incident, to something which becomes proactive alerting. This is something that we can actually bake into a change control process, pre-deploy, post-deploy snapshot. Show me anything new in the logs, a new signature, something that's anomalous, something that we haven't seen before. Doesn't necessarily have to be bad, it's just something unusual. And that can actually be investigated before we actually have an issue. The other thing that's powerful about this is the comparison target does not need to be the same as the baseline. So I don't need to compare my prod environment with my prod environment. I could compare it with my dev or my stage and actually see what is the delta, if any, between my two environments, which is sometimes really handy. So that's a sort of DevOps incident type use case using both metrics and logs. The other thing that I'll sort of drill into briefly is using something a little bit more of the now, so a Kubernetes type use case. So this is our Kubernetes Explorer that we've built. So basically this allows us to, this is heavily metrics driven. We still have logging and events in here, but we can show some different stuff here. And the secret sauce here is we allow you to pivot through your Kubernetes data using the mental model that people have for Kubernetes. Specifically, being able to go from what was traditionally an infrastructure-based view. So I've got my cluster here, I can expand it, I can see the nodes that I have, cluster level stats, CPU, memory, disk space, how many CPUs, etc. But when I actually want to go down a bit further and see what's going on with my applications, when I click on a node, I can see the pods running, but because Kubernetes is ephemeral and I've got pods coming and going, they're all distributed for availability, there's no particular rhyme or reason as to where the Kubernetes scheduler has decided to place a pod, which means if I'm looking for something in particular, an infrastructure-based view is not that useful. So what do developers tend to deal with when they have Kubernetes? They are dealing with services. So the service is what they are exposing to the world. They have a mapping service, a payment service, a web service, and that's what they care about. That's what is related to the customer reality. So they might say, okay, I know I've got my namespace here, Sumo Logic, and I know that I've got Fluentd. I can click on that service. It is ordered logically. It follows the mental model I have. I can see all of the related pods I have for Fluent, and I can see that they're all running fine. Easy to check, easy to say, no, the issue is not here. Everything's cooking just as we want it to here. So going into a bit more of a troubleshooting type lens, looking at my namespace here, I can see I've got my gauges for some stats here. I can see I've got errors in this particular namespace, prod loggen. I can see the security rules that I've got triggered, but just honeycomb status, visual check, I can see that I've got 2 pods which have got issues. So this one here says it's related to Carbon Black, and this one here says it's related to PagerDuty. So I want to have a look at the namespace. I can click on here. It can give me some options to drill down directly to the logs, all those error signatures from log reduce. But in this particular one, I'm just going to go into the namespace that's related and have a look at what's going on here. So I can see total number of pods, how many pods have failed, and which ones actually have errors. So in this case, I can see there's only one that's showing error logs, but I've got 2 that are in a failure state. So this one here, Carbon Black, I'm going to drill into the pod itself. And this is where we get into the metrics and discoverability side of the question within Kubernetes. This is all generated by Prometheus. So Prometheus has great service discovery, great metric instrumentation for Kubernetes. What we're sort of solving is the back-end challenges of scalability. But this information here, it's all just generated by a Prometheus operator. So I can see here that I've got a pod in a crash loop back-off state. And it's restarted thousands of times in the last 15 minutes. Events, I can see that there is a back-off restarting of the failed container that's being pulled from the Kubernetes API server. And I can see the containers running in a particular pod. Now this is really, really helpful. So this is just a timeline based on the metrics for the container or pod state. In this particular one here, I can see that it's telling me I've got my container status waiting reason. Going along, I can see the event where it started the container, and immediately after that, I can see that it's been killed. And the reason that it's been terminated is OOM killed, which is out of memory. So the Kubernetes scheduler has decided that it's eclipsed something and that one's going to be killed. And this is happening over and over again. So there's obviously something going on. My resource limits here, they seem to be okay, but we come down here, we can see memory usage, limits, and requests. So the request limit is what on startup the container actually asks from the scheduler. The resource limit is a policy limit that you generally enforce within a Kubernetes cluster on a basis of safety. You don't want people having memory leaks, or if you've gotten compromised and people are running crypto miners, you can set policy limits. Now, this particular one here is being eclipsed by the metric for how much memory the container is actually using. And that's why that is actually getting killed off. Now, there was not a single error log that actually told me this was happening, because it's getting killed by the scheduler. There's no log that's actually happening at the pod level. So if you don't have that instrumentation from the metrics within that sort of ephemeral nature of a Kubernetes container deployment, you really are flying blind. There's a lot of stuff there that you will only find either by polling the API server. So you've got a problem, you're sitting there at the command line with kubectl going, enter, 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 enter. Oh God, why can't I find this? No one wants to do that, so the metrics make this a lot easier to find. I'll just jump over for a second to my slides. So talk a little bit about how we've got to this point. So within Sumo, we've actually done this entirely with an open source collection strategy. So Kubernetes was open sourced by Google. It's now governed by the Cloud Native Computing Foundation, which is part of the Linux Foundation. So we've actually gone with a completely Cloud Native Computing Foundation governed collection set. So for our logs, we're pulling everything in via FluentBit. So FluentBit, if you're not familiar, came out of the FluentD project. It's a lightweight version written in C, low memory footprint, but doesn't have all the plugins and options that you get with FluentD. So lightweight log router, we use that to grab the logs from all the pods as they're coming out. We run them as a daemon set, so there's one running per node. Events, we're using FluentD to pull the events from the Kubernetes API server. Metrics, as I mentioned, we're using Prometheus. Prometheus, hugely powerful, really great auto discovering metrics instrumentation capabilities. The problem you get with it is scalability. You tend to end up with pods and silos of Kubernetes, of Prometheus. So we sort of send all that information from Prometheus to our scalable metrics backend. And on the security side, we're using Falco, which is a kernel level anomaly detection tool. All of this is fed through our enrichment pipeline, and actually every single log event metric and security event gets tagged with the service deployment namespace, as well as the node, pod, and container. And that's what allows us to pivot through those different views and get that sort of complete view that matches the mental model that people have for Kubernetes. So that's sort of like the key sort of things. That's a lightning round that I've sort of gone through a couple of different use cases, covering off a few things. As I mentioned, yeah, we do have some tracing stuff in alpha at the moment, which is really exciting. It sort of ties in a little bit to the stuff we've been talking about here, in that we've also gone with an open source collection strategy for tracing. The big reason for us was we started to see some industry cohesion and coalescing going on. So you had open tracing and open census sort of merge the projects into open telemetry. So we're starting to see things find a bit of a single way forward. But yeah, we've got customers in alpha now who are sending stuff both via open telemetry, but also via Zipkin and Jaeger, and also by pulling things directly from the service mesh. So from Istio and things like that, actually at the Kubernetes level for things that haven't been having code level orchestration. So that'll actually allow us to drill down beyond that pod level to the service, and then actually to the objects and traces below that. So I'm really excited about that. Any questions, please fire away.
Cool. Thanks, Eddie. Just gonna flick over to our other demo, our other slide share. So it's an open invitation really to understand where, understand any questions that we have from the audience here. If there's anything else people want to ask of Alan, myself, or Eddie around the concepts we presented, or around Sumo Logic as a tool, feel free to shout out. We've just got a couple minutes. I'm happy to stick around for a few minutes after that.
When do people find it helpful to be focusing on the sort of resource utilization numbers versus more the sort of the changes in outcome, you know, errors and request counts and all those sorts of things?
I mean, for a lot of our customers, it's a question of a bit of both. And it's really useful to be able to correlate between the two. If you've seen a spike in one and there is a correlating change in your resource utilization as well, they are your sort of different indications that sort of drive you in the way that you want to be investigating a problem. If you've just got one side, if you're only sort of looking at the application side without the infrastructure side, it's hard to get that whole visibility. And exactly the same if you've only got the infrastructure side without that application side as well. It's unless something is hitting a hard limit, you'll miss a lot of those sort of 10% problems.
Sure. I guess as was mentioned early on, there's so many signals that we can put into our sort of modern complex systems. Even if you just look at that, the picture that was there for the thousands of dials. It's just so easy to have so much that people get overwhelmed in dashboards and alerting and all those things. To wondering if people got other thoughts on sort of patterns to apply to what to actually put in a dashboard, what to put into an alert, and what to just leave for a more investigative part of the process.
I think, with what Eddie showed, those deltas over timeframes, what is brand new? What have we never seen before? There's something to be said about the entropy content of an alert or a log message or a metric. And for those really high entropy events, those are the things that are typically indicative of problems, in my experience, or hopefully they're indicative of problems. Those really low entropy events, if they're indicative of problems, you've got a really, really big problem. I think there's a lot to be said about, how valuable the entropy of a message is.
And I suppose the other thing is it's a question of knowing your audience. So the three dashboards I sort of pivoted through, one was what does the business care about? The other one is what does an engineer care about? And the last one was for a problem, an engineer wants to have this stuff to look at. So keep an eye on things which you are tracking your SLOs for. What are break it down into 5, 10, 15 key metrics that you care about the outcome of. If those deviate, have somewhere that you can then drill into the components that comprise that SLO.
Yeah, I guess, at the risk of invoking Conway's law a little bit, like if I had to think about working on a product team and thinking, what would I have to go to the product manager, the product owner to actually give them a heads up about? That is exactly the information I would want inside my dashboards or inside my alerting, just to kind of make sure that they weren't blindsided by it. Probably the signal that I'd be using to trigger action, and then all of the subsequent information in those dashboards, the insight, the data, just support the discovery about what the contributing causes of the problem really are. Cool. Any other questions from the group? Awesome. Hey, thanks very much for your attendance, for your contributions today. If you have any future questions that you want to reach out to Alan and I'm sure you can find us on the meetup invite. You can reach out to Assurity.com. We'll more than happy to help you with any inquiries you have.
As far as the meetup goes, if there's something you're interested in, you want us to try to get speakers around, please just send me a message in Meetup or email, or I have multiple channels you can contact me about what you might be interested in, and I can go and hunt for speakers on the topic. Yeah, I mean, just help us mine the network of thought leaders, and we will find those people. The cool thing is, is that in today's world, everybody is remote, and our chances for getting folks to speak for us is a lot easier. The ramp up is a lot easier. The only challenge is that we are in New Zealand time, so we have to just, you know, if we get speakers from the United States, we have to put these in the afternoon, you know, or in the early morning rather.
Rebrand the meetup from WellyOps to KiwiOps, or
Yeah, well, now we're national instead of Wellington, eh?
we can have Australasia Ops.
Yeah, APAC Ops. Yep. All right. Well, thank you very much. We'll schedule one here soon. Thank you. Thank you,
Thank you,
Eddie, as well for the
Thank
demo.
you, guys. Thanks for having me.
Cheers.
Cheers, guys.